I'm sure you've seen the green cans of Clorox wipes scattered all across campus. If you've ever been bored like me, you might have picked up one of those cans and skimmed the long list of pathogens that they kill, including E. coli, MRSA, flu, and more. But one category of pathogens that is notably missing from this list is spore-forming bacteria. Spores are a dormant form of bacteria that are able to survive in extremely harsh conditions. In fact, some spores are even able to survive being put in a pressure cooker, which would kill every other form of life. When spores encounter a more favorable environment, they can exit their dormant stage and start to grow and multiply. Now, only some bacteria are able to form spores. What's interesting, though, is that bacteria that can form spores are resistant to some antibiotics that non-spore-forming bacteria are susceptible to. For example, spore-forming bacteria are resistant to the antibiotic monoamicin, which is used in the agricultural industry. And so, an active area of research is looking at what might be causing this resistance. Now, most antibiotics work by disrupting proteins that build the bacterial cell wall. The cell wall is built like this. First, these building blocks called lipid 2 are polymerized or linked together into a chain. These chains are then cross-linked together to form a layer of peptidoglycan. We can compare this to building a brick wall, where polymerization is cementing bricks into a row, and cross-linking is cementing rows of bricks on top of each other. And so, for my thesis, I looked at the protein SpoVDE from the pathogen C. difficile. SpoVDE is a protein that is only present in spore-forming bacteria and only active during spore formation. C. difficile is currently the #1 cause of hospital-acquired infections. This is because their spores are resistant to disinfectants, like Clorox wipes. In particular, I showed that this protein complex SpoVDE is able to polymerize lipid 2 molecules together. That is, they're able to complete that first step in building the cell wall. We're also able to show that SpoVDE can polymerize lipid 2 even in the presence of monoamicin. Now, that is why this research is significant. Monoamicin targets proteins responsible for making non-spore cell walls. SpoVDE may be the reason why spore-forming bacteria can survive monoamicin treatment. Because SpoVDE is involved in building cell walls, it would be a prime target for future antibiotic design. And so, in conclusion, even though our Clorox wipes can't kill spores, we can use what we learned about SpoVDE to work towards creating other effective treatments against them.